Okay, welcome to today's lesson. This is 1.6 again. This is day 2. So this is where I'm going to summarize what we found in our investigation yesterday. This lesson does not have a handout, so you're going to have to pause the video every once in a while and copy down what I've got here. So going through, I'm going to cover this up so it doesn't get too overwhelming. On the left-hand side here, you can see I'm going to talk about what's the mathematical notation, and then how would I describe the transformations in words, so whenever it asks me for that in my lesson. So all of my questions are going to start by telling me y equals f at x, and this is going to tell me what the parent function is. So this might be the radical function, it might be the reciprocal function, it might be the quadratic function. Now from there, I want to know what happens if I put an a multiplier out in front of that original function. So remember, f at x is just going to be maybe the absolute value function. So I've got some number a in front of the absolute value function being multiplied. And we know that it doesn't matter what this function is, that a number in front is going to be a vertical stretch or a compression. And it depends on how big the number is. So what you do is you look at the a value and you ignore the sign. So I don't care if it's positive or negative. I'm just going to consider the number. And if the number is bigger than 1, then I'm going to see a stretch. And if the number is between 0 and 1, so like a fraction or a decimal, I'm going to see a compression. Now the other thing I need to think about here is if the a value is positive or negative. If a is negative or less than 0, then I'm going to have a reflection in the x-axis. Or a vertical reflection is another way to say that. Next, I want to think about, okay, so I've dealt with that a value, but now what if also I subtracted a d inside the function? So notice here that the f, whatever that function is wrapped around the x minus d. So if the function is the absolute value, then the absolute value bars are wrapped around the x minus d. Or if the function is the square root function, then the square root is wrapped all the way around x minus d. So that's how I know where the function ends. That means that the minus d is inside the function, and so it is my horizontal translation. Instead of translation, if you want, you can use the word shift as well. So it's a horizontal translation, and it's going to be d units either left or right, and you need to think about which direction. Don't forget that it's usually the opposite of what you might think. And then next I want to think about what happens. I've already dealt with this a, that's my stretch, reflection, or compression. I've already dealt with the d inside the function. Now I'm going to add c outside. Notice that the function, the f, is not wrapped around the c. It's only wrapped around the x minus d. So this plus c would come after the absolute value bars, or after the fraction, or after the square root. And that plus c is always going to be my vertical translation or my vertical shift. I'm going to go c units up or down with all of my points. The order that I did these things in is kind of important. So what I want to always do is my stretch, compression, reflection first, just like I do my multipliers first in BEDMAS. And then in BEDMAS, I would do my addition or my subtraction. That's why my translations have to come second. So always the stretch, compress, reflect first, and then translations. All right, now we're going to talk about what do the equations turn into. That final equation here of g at x equals a times the function, all wrapped around x minus d, plus c, because sometimes this can be confusing. So in the textbook, sometimes they're going to tell you if f at x is the x squared or the quadratic function, and g at x is equal to this thing, they might have a number in for a, d, and c. How can I rewrite the g at x function with the squared in there? And what I'll say is that g at x is equal to whatever the a number is. So I'm just writing this out here, and when I get to the f, I need to replace it with the squared. So the a number is going to be the same. And then the f function, that's how my squared function, needs to wrap all the way around the x minus d. So I'm going to take the x minus d, and instead of writing f, I know that the function is square it, so I'll square that whole bracket. And then I put the plus c at the end. So this is just another notation that we need to get used to. We're going to try that again, but now with a different function. So again, g at x is equal to a times the function of x minus d plus c. But this time, my function that I'm going to be using is the square root function. That means I need to wrap the square root around this whole bracket x minus d. The a and the c are outside of it. So I get g at x is equal to a, and then I wrap the square root all the way around the x minus d, and the plus c comes after it. I put a little tail on my root just to show where it ends, but you don't need the tail. Next, we're going to take a look at the absolute value function. Same thing, the function wraps all the way around x minus d, so I know that that's where my absolute value bars are going to go, around x minus d. And then our last one, what if the function was 1 over x? So this one's a little bit tricky. Here, the x is in the denominator. So that means that whatever I'm taking the function of is going to end up in the denominator. So the x minus d is going to end up in the denominator. The a is going to be in front of the function, and the plus c is going to be after the function. You can keep it in brackets if you like to show the multiplication, but you don't need it there. In fact, I don't have a ton of room here, but some people will rewrite this and they'll multiply those two fractions together. So they're going to think about the a is the same as a over 1. And to multiply two fractions, I multiply the numerators, a times 1, and I multiply the denominators, 1 times x minus d, and then I add c afterwards. So these two expressions are the same. Whether you put the a out front like this, or whether you put the a in the numerator, it doesn't make a difference. All right, so we're going to take a look at an example. And in this example, they've told me that the g at x function is equal to -3 times whatever the function is. I don't know what we're doing yet. Maybe it's squaring, maybe it's square rooting, of x minus 2 plus 1. So the first things they want me to tell them is what transformations were applied. I still don't know what the parent function was. I don't know if it was the reciprocal or the radical, but I also know it doesn't matter. Transformations are the same no matter what the function is. So I start with my multiplier out front, the -3. The negative tells me that there has been a vertical reflection or a reflection in the x-axis. So that's because there's a negative multiplier. Now the 3, when I ignore the sign, the negative sign, the 3 is bigger than 1, which tells me that I have a vertical stretch. The factor for that stretch is 3, which means I'm going to multiply all the y values by 3. Next, just moving along my function, I've dealt with the -3. I don't know what the function is, that doesn't matter. I'm subtracting 2 inside the brackets. And I know if it's happening inside, it's horizontal. So I'm going to have a horizontal shift or a horizontal translation. And you need to tell me where are you going. We're going 2 units, and we need to know which way. It looks negative in the equation, so that means I'm going to move to the positive side of the graph, which is the right side. And then the last thing in the equation is this +1 afterwards. It's adding, so I know it's a shift, and it's outside the brackets, or outside the function, so I know that it's vertical. So I've got my vertical shift, and I'm going 1 unit, and because it's vertical and positive, I'm going up. So that's describing the transformations in words. Next, I want to know what's the equation if f at x is the x squared function. So now I'm going to go back into this equation, and instead of putting an f in, I'm going to put the squared all the way around that bracket. Everything else will stay the same. So I can say that the equation then would be g at x equals, my a value would still be out front, and now I'm going to wrap my function, my squaring, around that bracket, and the plus 1 comes afterwards. We'll try it again. This time we're going to pretend that the function is the square root of x. That means I'm going to wrap the square root all the way around the bracket. My a value is still out front, and this time I'm wrapping the square root around x minus 2. The plus 1 comes afterwards. We're going to do it again, this time for the absolute value function. So again, I'm going to wrap those absolute value bars around the x minus 2. So g at x is equal to my a values out front. Inside the absolute value bars, I have x minus whatever your d value is. It's minus 2 in this case. And then the plus 1 comes afterwards. And then our last one here, again, the function is 1 over x, which means that all the x stuff needs to go in the denominator. That means everything in the brackets here, remember it's normally f at x, now x is being replaced by x minus 2. So x in my equation will be replaced by x minus 2. The negative 3 is still out front. I get 1 over, x minus 2 goes all in the denominator now, and then the plus 1 goes afterwards. Don't forget that you can multiply this in, so another way to write this answer would be to put the negative 3 in the numerator. Have x minus 2 is still in the denominator and plus 1 still coming afterwards. So 2 possible answers for that last one.